But to start with, I want to tell a little bit of a story from my own life. So in 2019, I used to work at Uber, and my office was up here or my home is here in the Bay Area in San Francisco. And my office was up in the actual city of San Francisco. Now, this is about 55 kilometers between my home and my work. And I would commute this distance on a daily basis, and it would take me nearly an hour and a half each way to go from home to work and back to home. I think that during the pandemic, as many of us shifted to work from home, we started to think about the value of our time. How much time are we spending like this, commuting, sitting in traffic, going relatively short distances, but taking a very long amount of time? And so now around the world, as many people have returned to a more normal pattern of life, we've seen traffic and congestion return, and it's something that we now deal with on a daily basis again. And I know that even in my time here in the last few days in Seoul, I've been amazed at how much traffic there can be to go a relatively short distance. And I keep asking myself, there must be a better way. What can we do better? How can we move? How can we free up the time that we have to spend more time with our loved ones, more time doing the things that we really enjoy, which is generally not sitting in traffic? If you think about it, it's pretty amazing what we're willing to tolerate. Just in the US, we're talking about 360 million wasted hours per year, people sitting in traffic. And if you look at the more globally, we're talking something more like 4.6 billion hours wasted per year sitting in traffic. Now, this is 2019 numbers, pre-pandemic, but we all know that this is where we're headed again, if we're not already there. It doesn't have to be this way. If you look at the start of transportation, there's so much, the ability of transportation to catalyze amazing changes in the way we live and the way we work, whether or not it's the train, automobile, or the airplanes, have given rise to whole new paradigms of life, whole new ways of communicating and working and living together so that we can visit in mere hours and travel across the globe. But as these revolutions have progressed, we've seen that they change from the open road, where it's amazing to be able to drive, to this congested, clogged up freeways that you sit for hours and hours in of your time. And it's true, not just for automobiles, but for all of these transportation revolutions. And then it's really cost prohibitive even to solve it. You can't build your way out of this. In the US, we're talking $250 million per mile of highway to be built. And these costs just go up. And it's not just the cost from a dollar standpoint, it's the cost from an environmental standpoint. 29% of carbon dioxide emissions worldwide come from the transportation sector. We think we can do better than this. We think that one of the solutions is to take a page out of cities themselves. Cities have become these dense loci of human development and human flourishing because they've been able to take advantage of connecting people together, and they've built up. Cities have grown into that third dimension in the way we live. We think transportation can also take that step into the third dimension. So not just will it be cleaner and easier, but we can actually take advantage of that additional space. So what would this look like in a city like Seoul? Well, you can imagine going from here in Jeonggu to Incheon. Instead of sitting in traffic for 70 minutes, we could fly there 15 to 18 minutes. And you know what time you're going to get there. It's not just the time, but it's also the certainty of knowing when you're going to get there. So we actually have been working to make this a reality. We have a partnership at Joby with SK Telecom, who's an amazing partner. We've been starting to really understand patterns of movement and patterns of data, and how do people actually travel today in cities like Seoul. But let's just take for a moment, this is all of Korea. This is about 46 million trips on a daily basis that we're modeling here in terms of looking at where people come and go. So in this animation, white is representing where people depart from, blue is representing where people arrive to, and this is a 24-hour loop, so you can see that the pulse of movement rises and falls on a daily basis. We can then look a little bit more closely at this, zoom into just the greater Seoul region, and we can see that there's so much density and so much movement that's happening on a daily basis here, and you can actually see how the flows of traffic shift from in to out to into. It's like breathing in the city. So we can start to really understand what these types of movements look like, what this type of data tells us. Just zooming in on the city of Seoul, this is an example of just long trips. So these are, this is kind of a heat map of people either arriving or leaving on long trips, which are defined as like 45 minutes or more. So many long trips that are happening. From this, we start to derive, we can start to understand where people want to go. And we can look at this on a more granular basis and then decide where should you put infrastructure, where should you put the takeoff and landing spots for this new type of three-dimensional mobility. But it's really important. People have tried this in the past. People have tried to make three-dimensional transportation with things like helicopters. And really, if you think about it, there's a combination of things that must be true to make this type of mobility work. You have to have the right mission. You have to have the concept of like, how is this business going to actually work? And then you have to have the right machine that can meet that mission. So let's start with the idea of the mission first. This is a look at a potential series of trips in Manhattan, in New York City. So the idea is that by combining ground and air transportation together, we call this truly multimodal, we can actually make this mission work. We can actually pool people into cars and actually progress that idea of not just electric mobility, but shared electric mobility. That's every trip taking more cars off the road in order to not just make the trip easier, but to make the overall city better. So this is the basic idea of like how this type of a mission would work, we believe. So what would it look like from a consumer basis? So it's going to be on-demand transportation. This is one of the things that we've seen has taken off in so many places around the world, and I know that the vast majority of trips are now starting to be booked in apps, whether or not it's taxi trips or other types of trips. In the U.S., it's a little bit different than Korea in terms of how these types of on-demand trips work. But fundamentally, it's the same idea. You're going to be able to pull out your phone. You're going to be able to select an on-demand trip from where you are, from your origin. And so what we'll do is we'll actually then be working with a partner, with our partners at SK Telecom here in Korea, and with TMAP and with UT, to actually get you a car from where you are to the nearest place where you can take off. So you'll be able to, basically it'll be seamless. You'll get in the car, it'll take you to the nearest skyport. You'll board along with several other people who will be pooled into the same vehicle simultaneously so that we can make the economics even more favorable. And then whisk to your destination at up to 300 plus kilometers per hour flying through the air. When you get to the destination, a series of taxis will be dispatched to meet you there and take you to where you actually want to go, to your final destination. All seamless, without you thinking about it, single price, all done through an app. You have to have the key characteristics to make this work, though. And so this is what some of the things that we've been designing for in the aircraft that we are now working through the certification process with. I'll talk a little bit more about that in a minute, and bringing to market. So we have 4 seats. So we have space to be able to pool multiple people into the aircraft, again, to make those economics work favorably. We have the range. We can actually fly the missions that you need to reach on a daily basis and cover the vast majority of trips for where people want to go. We have the speed. Speed's incredibly important because we have to provide utility. We have to get you there faster and better and more conveniently than any other form of transportation. And we think it's key to be piloted by a human. This allows us to get going faster from a regulatory standpoint and actually start to operate this service with these vehicles as soon as we possibly can, as we get the machines themselves certified. And finally, it's important, we think it's really important to be quiet. One of the key things that's kept three-dimensional mobility on a city basis, on a local basis from working is noise. People don't like helicopters taking off and landing near them. It's too loud. They also, what they like even less is helicopters flying over them because it's still really loud. And so we've done a lot of work, done a very, very significant amount of engineering to make the vehicle that we're making quiet. I'll talk a little bit more about that in a second as well. And it's not just quiet. We think it has to be really quiet because this is a differentiator that's going to unlock these markets and allow the community acceptance of this new form of aerial mobility to literally take off in cities around the world. So we talked a little bit about the mission. Let's talk about the machine. So at Joby, we've been working on this for a while. Joby started back in 2009, and we started understanding and working with partners in the US in 2010, 11, 12. This is an example. This is not a flying truck, just to be clear. This is an experiment that we did with NASA back in 2012, 2013 on understanding distributed electric propulsion, starting to really scratch the surface of this new form of technology, this new form of propulsion that could then be applied to make these revolutionary new types of vehicles. We flew our first subscale model, I think in 2015, and then we flew a full-scale, large, heavy vehicle that went through the entire aerodynamic regime of taking off vertically, converting to forward flight, and landing vertically in 2017. So this is our refined prototype that we're flying now. It's really, it's a pretty remarkable machine. It has 6 rotors, or 6 propellers actually, we call them, that can tilt from a vertical position like this to allow you to take off straight up like a helicopter, and then tilt forward to convert into an aircraft. And so when it's converted to be into this forward flying configuration, it flies around just like any other airplane, except that it's very quiet. If it flies over at about 300, 400 meters, you won't hear it. It's that quiet when it's in that cruise mode configuration. And then to land, it just reverses that process. The propellers tilt back up to that pointing up configuration, and then it lands straight down, just like a helicopter. But what's very unlike a helicopter is that it turns off. That when it lands, see right there, everything turns off. There's no cooling down. There's no sitting on the ground making tons of noise, lots of racket that bothers people. This is one of the very interesting features of electric propulsion that is a little underappreciated, I think. That you have very, the profiles of utility, the profiles of utilization of these types of vehicles allow you to roll the airplane out, you turn on, you take off, and you fly away. And you're only in that takeoff mode where you make a little bit more noise for a few seconds at most. So to really understand the noise profiles better, we actually have been doing work with NASA recently in the United States. NASA, for those that don't know, is the National Aeronautics and Space Administration, so the US government agency equivalent of CARI here in Korea. So we've done a lot of work to design these propellers to be very quiet. So that's not just it's the size, it's the shape, it's the details of the way the blades are actually contoured, it's the way the tips are shaped, it's all of these things combined with the design of the electric motors themselves that have to go together to make something quiet. Quiet is not something you get for free from electric propulsion, at least not in aviation. You have to work for it. But electric propulsion enables you to actually do that work, whereas it's more or less impossible with conventional forms of propulsion. So we did a little demonstration of this last year, actually. We had a series of aircraft fly over, and this is just a little clip of that. And you can see the sound profile demonstrated graphically here of these different types of aircraft, conventional aircraft, helicopters, big helicopters, small helicopters, and this is the Joby aircraft. So like I said, when it's flying over, it's remarkably different than any other aircraft out there, basically silent as it flies over where you are in the ground. We then actually did some more work with NASA as part of the NASA Grand Challenge, which has been ongoing for a couple of years here, but we just did this work back in August and published the results recently, where NASA distributed an array of microphones. We flew many different profiles over that array of microphones, which allowed us to build acoustical models with the NASA team that represent the way these aircraft sound. And then we can use those acoustical models to then project that sound into different scenarios where we can't yet test. So we can have a cityscape, or we can have other types of environments that we can use this model of the noise to then project it into that environment and allow us to understand even more how these noise profiles, what they feel like, what they sound like in everyday life. And from this, it confirmed our predictions, which we were really excited about just exactly how quiet these vehicles are. So at 500 meters, we're at about 45 dBA. which again is remarkably quiet. It's that the fan here in the room is louder than that level. When we're taking off a landing, again, this like very short in time phases, very important, but very short in time phases of how this vehicle operates. We're below 65 dB when the aircraft's only 100 meters away. So we think we've nailed it when it comes to the sound profile of this aircraft. And this new profile is a new capability that you simply can't get from anything out there today. And this will allow us to unlock community acceptance of this type of transportation as we bring it to cities around the world. So we've got the right mission. We've got this quiet machine that we've spent so much engineering effort on over the last 10 years. But we think it's also critical that we keep sustainability at the top of the list of our priorities. So we have 0 operating emissions. En route, it's all electric. And so every car trip that we replace, we are replacing it with a 0 operating emissions trip through the air. And these are very efficient vehicles too. So it's actually on an energy use basis on a per seat perspective. It's very competitive even with ground transportation. So in summary, what we've worked to do is to bring this new form of mobility to the world through the engineering work that we've done, through the understanding of movement and of data, understanding what the right mission is, to be able to make this work as a product, as a business, so that we can bring it to places around the world. We're incredibly excited to be working with our partners at SK Telecom here in Korea. And we're looking forward to being able to bring this new type of vehicle, this new type of technology, and enable air taxis, aerial ride sharing, UAM, all of the different ways you can describe this new mode of movement to here in Korea in the near future.
지금 그 언론 보도에 따르면 미국의 그 FAA에서 그 eVTOL 인증에 대한 기준 변경 이슈가 좀 있는 걸로 알고 있는데요. 관련해서 저희의 그 상용화 시기 목표가 혹시 1년에서 2년 정도 늦어지는 거 아니냐라는 우려가 있는데 이에 대해서 어떻게 생각하시는지 좀 말씀 부탁드립니다.
Yeah, thank you for the question. So what the question is referring to is that the FAA has been publicly reported that the FAA has changed certain aspects of the way the certification process is done. It's not really a change in the standards, however. It's a change. It's effectively a bureaucratic change. There's it's a different pathway in terms of like the way all of the approvals are categorized within the set of rules and regulations for the FAA. So one of the really exciting things is that we've been working very closely with the FAA through this kind of paperwork change in the way that they're approaching certification. And we've already gone through the entire revision of the initial work that we had done over the last few years, over the first couple months after this change was made. And we're not anticipating any changes to the actual standards or regulations as a result of this. It's effectively a formatting change. It's a certification, so it's a lot more complicated than that. But effectively, it's a bureaucratic change in the way this is handled. And then it has more of an effect on the operating rules for pilots and operations in the U.S. And the FAA has committed to work with industry to make sure that those changes necessary on the operating rules and piloting rules side, as a result of this paperwork change and the way the certification is done, don't affect our timelines.
네, 질문 기회 주셔서 감사합니다. 저 궁금한 거는 결국에는 상용화의 핵심은 가격 전략일 것 같은데 이 가격적 전략에 대해서는 어떤 좀 계획을 짜고 계시고 실제 처음에 시작됐을 때 가격이 어떤 식으로 될지를 좀 알 수 있을까요?
Yeah, thank you for the question. From a pricing perspective, it is true that the demand of consumers for this form of transportation or any form of transportation is essentially elastic to price. And so we've done a lot of work on this in the U.S. where we've focused over the last few years. So I used to run the Uber Elevate team before Joby acquired the Uber Elevate from Uber, and now I lead the same efforts inside of Joby as we define this product that we're bringing to market. We did a lot of work on modeling networks within cities, including modeling price elasticity by consumers. And so we actually survey people, do thousands of surveys to build an elasticity model of how consumers see price for this type of transportation, depending on time savings and demographics and location and all different aspects that go into this kind of probabilistic model of a consumer and what they would pick on a regular basis to take a trip. And so we are actually refining this methodology, and we will be using it in places around the world as we look at opportunities to deploy. So that gives us a perspective on elasticity. Of course, cost has to match the price, right, in order to make the business work. And so we're doing careful modeling, and costs are different in different markets. And so we have to be careful and look at that and understand the details around that aspect of the service. But we're taking a very first principled approach to this. So we're building it up from the ground up. We're looking at this in terms of what are our costs, what are the elasticity of consumers, how do we bring these things together, and then make rational choices as to how we run the business as a result of that. Our goal, though, so that all being said, that's, we think, the right principled approach to assess the market and to make plans. But our goal is that we're able to launch this service, at least in, we think about the markets that we'll launch into as kind of focused on the US initially, because that's where we're doing our certification. So we're thinking in the US that the launch price will be similar to an Uber Black, which is kind of a premium Uber a car right now. But then as we develop the efficiency of the network and able to drive the load factors higher in the aircraft and the utilization of the aircraft higher, which is largely an operational exercise, we'll be able to drive the price down closer to that of an Uber X on a per seat mile basis. So not a vehicle, but on a per seat mile basis. And we think that's pretty realistic. It'll take a little bit to get there. But our investigations into price elasticity from consumers suggest that actually works as well as an entry point that will allow us to start developing the network and get it going.
eVTOL의 궁극적인 미래는 결국은 조종사가 없는 드론 형태가 될 것으로 예상을 하는데요. 실제로 위스크에어로 같은 경우는 파일럿을 뺀 건너뛰고 바로 이제 그 무인으로 가겠다라고 하는 회사들도 있는데 전문가로서 보시기에 그 조종사가 없는 모델이 실제 상용화가 되는 건 언제쯤 정도로 될 걸로 보시는지 궁금합니다.
Yeah, so it's a very good question. It's a subject of a lot of discussion, and different companies in this space have taken different approaches to this. Our philosophy and the approach that we've taken at Joby is that starting with a piloted vehicle, so a pilot inside of the vehicle, flying the vehicle is the best and most efficient way to come to market fast. And we think that getting to market quickly and actually starting to be able to develop the market and develop the network and interacting with consumers is the most important thing. The challenge from a technical standpoint of a self-piloted aircraft, and it's not really unpiloted because it's piloting itself, right? So the equivalent of an autonomous vehicle, but in the sky. We believe that technically it's actually a simpler problem than AVs on the ground. That the amount of understanding, there's basically not the same number of corner cases in the sky, which are the things that kind of eat you alive in autonomous vehicles on the ground. However, from a regulatory standpoint, it's a lot more of a difficult problem because of the way aviation is regulated around the world. It's pretty similar and consistent. And you have to have a pretty high assurance that, because there's very high consequence when things go wrong when vehicles are flying. And so we think it is the right approach. So it's going to be a convergence of both the technology improving and the regulations starting to be able to find ways to incorporate that technology in a safe way into the regulatory framework. I'm not going to hazard a guess as to when all of that happens, because when regulations, and it actually requires change in regulations. And so when you require change in regulations to happen, there's a very uncertain time frame associated with that. But I think it's going to be a while before we see self-piloted flying vehicles carrying humans for commercial purposes on a regular basis, outside of maybe a few stunts, happening pretty much in any of the civil aviation kind of regulated countries. But I should add, I do actually think that in the long arc, it is certainly where the technology is going. And so we see it as like a way to you know, you have a pilot, you are the aircraft itself is very automated in some sense. So they have six propellers, sorry, they tilt. The pilot's not moving six levers at the same time, right? The pilot is simply saying, go forward. And then the machine does the right thing. So there's a lot of automation built into the aircraft already. And we see that as like there's a stepping stone process where more and more over time we'll upgrade the aircraft to add more automation, make it even simpler. And I think that converges from a technology standpoint with that inevitability of self-piloted aircraft where the pilot doesn't really have to do anything. And the safety case is such that the aircraft takes care of itself. And I think that's how we get there ultimately.
제가 2018년도에 에릭 대표님이 우버 에어 계실 때 그 신대원 사장님하고 같이 발표하신 거 굉장히 감명 깊게 들었습니다. 근데 그때는 이제 소속이 우버 에어셨고 지금은 조비이기 때문에 사실 서비스의 주체냐 아니면 하드웨어를 만드는 주체냐에 따라서 약간 생각이 좀 다르실 것 같은데 우버하고 관계를 어떻게 설정하실 건지 일단 궁금하고요. 한국에도 그 이후에 이제 UAM에 대한 많은 니즈가 있었기 때문에 지금 현대, 그다음에 롯데, 한화, SK, 카카오 굉장히 많은 업체들이 이 서비스 내지는 기체 제작에 뛰어들었습니다. 당장 이제 레귤레이션도 굉장히 많은 상황에서 이 많은 업체들이 뛰어들었는데 이 항공의 어떤 그 질서라든지 아니면 각각 주체들이 협업할 수 있는 기회가 있을지 그런 것들이 좀 궁금합니다.
Thank you for the question. I do think there's room for collaboration. I should just be clear from my perspective. UAM is aviation. It is, we're going to be flying people around for compensation commercially. It's not going to be long distances like a conventional airline is, but we're effectively taking an airline network that exists over like the whole country and shrinking it down to a city and speeding it up. So that's what technology lets us do. But that's why you actually have to have both the technology of the platform and the technology of the vehicle kind of brought together. And so my personal philosophy hasn't changed too much in the sense that I think you still have to build all of these pieces of technology. I think that from Joby's perspective, we've been working on this for a while, and we think that we are in a pretty good place in terms of where our technology is relative to others in the market, and the path that we're on to get through certification, which is a very difficult thing. When it comes to pre-market approvals for technology, aviation sets a pretty high bar compared to just about anyone else, any other industry in the world. And so we're pretty comfortable with where we're at in terms of that process that we're working through, where we are relative to other people. I do think, though, that fundamentally aviation is a regulated space, and so we have to work together across different potential competitors down the road as we work with regulators, as we work with communities, as we work with all of the stakeholders in terms of who is necessary to bring along to make this type of mobility a reality. So we're definitely, we're really excited to have an incredible partner like SK here in Korea. And we're building partnerships in other parts of the world as well with other people. And we're definitely continually open to collaboration and working together because we know that this is not something that one company or even one group of companies does alone, but rather it's a new form of mobility, and there's going to be room for lots of players in this space over time.